Hi, my name is Kimberly. I'm a PhD student at Monash University, and today I'll be talking to you about student development of problem-solving skills using metacognitive scaffolding. I'd like to start off my talk by acknowledging the traditional owners of the land on which I'm presenting today and pay our respects to the elders past, present, and future. Problem solving is a fundamental skill in chemistry, but unfortunately students have difficulties with this skill, and that could be due to a variety of reasons, such as the inability to extract relevant information from problems, meaningless manipulation of mathematical operations, or due to a lack of self-confidence in problem solving. Our research group has developed a problem solving scaffold known as Goldilocks Help, where it takes students through the elements of the problem solving process, such as understand, analyze, plan, implement, and evaluate. So within each of these elements are prompts. For example, with analyze, the students are asked to identify known and unknown data, and in plan, they're asked to establish a relationship between known and unknown data. Despite this being a tool to help students establish and develop structured problem solving, some students are engaged with this scaffold, and that could be for a variety of reasons. It could be due to, it could be cognitive, for example, a lack of chemical knowledge. It could be behavioral, for example, focusing on just getting the right answer. And so we want to understand why students engage or don't engage with the scaffold. And for the purpose of today's talk, we want to explore the questions of how do students engage with the problem solving scaffold? Why don't some students engage with the problem solving scaffold? This study is underpinned by two theoretical concepts, metacognition and scaffolding. Metacognition is the ability to monitor and critically evaluate one's understanding and learning / problem solving processes. And metacognitive awareness falls into knowledge and regulation of cognition. So knowledge of cognition involves knowing what, how, and when to apply knowledge, and regulation of cognition involves a process of planning, information management strategies, monitoring, debugging strategies, and evaluating. Scaffolding is a pedagogical process that enables a novice to complete a learning task that could not be completed / accomplished unassisted. The data that we'll be exploring in today's talk are some student in-semester assessments, and the in-semester assessment is a two-part assignment where in part one, students are given a problem and asked to submit their solution to that problem, as well as a self-assessment on how they think they went. And in part two, they're given the expert solution and asked to submit their reflection on how they think they went in their solution, now with the knowledge of what the expert solution looks like, and again, self-assess their abilities. This two-part assignment was administered across the semester 4 times, and so the cycle of solving a problem and reflecting on their solution was carried out 4 times in this semester. The two-part assignment was analysed using frequency analysis, and that was carried out by looking at it from 3 different perspectives: by topic, by participant grouping, all students, successful and unsuccessful students, and this was determined, a student was determined to be successful if they got the correct answer. By a measurement point, student solution to the problem before exposure to the expert solution, student comparative reflections after exposure to the expert solution, and student self-assessments before and after exposure to the expert solution. Next, the student comparative reflections were thematically analysed using the Braun and Clark approach, and there were approximately 150 submissions per topic, 4 topics, and each submission ranged from half to a page. This study was approved by Monash University Human Research Ethics Committee. On this slide is an example of a student submission to the two-part assignment. In part 1, the student submits their solution to the problem, and then they self-assess their abilities to use the problem-solving elements of understand, analyze, plan, implement, and evaluate on a scale of full, partial, insufficient / none. And they made this assessment based on the problem-solving rubric that we provided them. In part 2, once they were given the expert solution, they reflected on how they think they went, and this is an example of a reflection that a student made. The student says, although an evaluation was made, it was not recorded. Hence, next time I should write down if the solution seems correct and reasonable, and then record down a statement. And again, they ask you self-assess their abilities to use those problem-solving elements on a scale of full, partial, insufficient. And you can already see here, the student changes their mind from, in part one, they believe they're fully engaged with the element of evaluate. And then in part two, once they now have seen the expert solution, they reassess and they think that they partially engaged with evaluate. The frequency analysis was conducted by scoring the solutions, the student solutions using a problem-solving rubric, tallying the student self-assessments, and scoring the comparative reflection using a separate rubric where we looked for multiple factors. For example, we looked at whether they were able to identify similarities or differences between their solution to that of the experts. From the frequency analysis, we were able to capture the students' use of the problem-solving elements for all students across the entire semester. So starting at the beginning of the semester in topic 1, followed by topic 2, 3, and then at the end of the semester in topic 4. And within each of the topics are the problem-solving elements of understand, analyze, plan, implement, and evaluate. And within each of the elements are the level with which they engage with the elements on a scale of full, partial, none, / insufficient. And the main takeaway from this visual is that as the semester progressed, the students more consistently used the problem-solving elements, as you can see here with analyze. So in topic 1, 19% of students fully engaged, and that gradually increased. And by the end of topic 4, 77% of students fully engaged with analyze. It was also, it should also be noted that the problem-solving elements of evaluate and understand were more difficult for students to master. For example, in topic 1 and 2, 89 and 56% of students did not engage with evaluate at all. And in topics 2 and 3, 54 and 44% of students did not engage with understand. And we hypothesize this is due to the fact that these problem-solving elements require deeper thinking, better language skills, and understanding of concepts. For all student self-assessments, for example, in topic 1, it tells us that observing the model and solutions made students more metacognitively self-aware and self-critical. Successful and unsuccessful student data, for example, in topic 2, shows that successful students demonstrated problem-solving elements more effectively. Next is thematic analysis. So the comparative reflections were inductively analysed with a focus on the development of problem-solving skills. And so in order to see how students and their problem-solving skills progressed over the semester, we looked at an individual student and their reflection across the entire semester. So in all 4 topics before moving on to the next student and their reflections. And this analysis is ongoing. From the thematic analysis conducted, we identified some themes, and below are some of the representative themes. So students were able to identify flaws in their own solution that were related to general problem solving skills, and also flaws that were problem specific. For example, the student says, I did not understand at the beginning this was a partial neutralization buffer preparation question. Some students identified potential points of error that could be avoided. The student says, the scaffold could be implemented in the future to minimize calculation errors. Some were able to identify specific mistakes or a mistake that led to the wrong answer. The student says, the formula was correctly identified but written incorrectly as there was a negative missing leading to an incorrect answer. Once looking at the expert solution, some students found that their problem solving, they found to be more confident in their problem solving skills. The student says, after looking at the expert model answer, I was able to solve the question with a much greater degree of confidence. Some found that the scaffold prompted improvement strategies. The evaluation was done poorly. I should have inputted the obtained data point to prove that the left-hand side equals to the right-hand side. If this was done, I would have noticed that an incorrect pressure value was inputted. Once looking at the expert solution and using the scaffold, it improved student self-awareness. And however, some students, once looking at the expert solution, became overly critical. So the student says, my solution to the assignment was not close to as good as his or hers. It was a complete loss of time and had no focus. Some believe that the lack of confidence was a stress factor that impacted their ability to perform in the two-part assignment. The student says here, I feel as though my lack of confidence with this topic has led me to perform poorly. They were able to assess the depth of their solution in comparison to that of the experts. Students were also able to identify points in their solution that they performed well. And most importantly, some students found that as the semester progressed, their problem-solving skills also improved. As the student says here, the preparation is improved, more logical, more sufficient comparing to last time. So overall, the in-semester assessments showed us from the frequency analysis that repeated cycles of the two-part assignment showed greater student engagement with structured problem solving. Reasoning skills such as evaluate were more difficult to develop. Exposure to the expert solution provides students with the opportunity to reflect and become more self-critical. And from the thematic analysis, the opportunity to reflect on the expert solution gave students the ability to identify flaws in solution and improvement strategies. And most importantly, for some students, we found that there was progress in their problem-solving skills as well as their ability to reflect on their own problem-solving skills. I'd like to end my talk by acknowledging my supervisors, Elizabeth, Mabub, and Paul, for their much appreciated guidance, and the participants, the students involved. Thank you for listening.